All right. What I want to talk about today. So we talked about the scientific method. I want to do a quick review of this to make sure you understand why we have the scientific method. You're going to need it today. You read the problem, you identify what your problem is asking you to do. Then you hypothesize what you're going to need to have. You use deductive reasoning, come up with a procedure. You call back to all your things you have memorized. That's deductive reasoning. You collect data, which takes inductive reasoning again, and then you come up with a conclusion. You look at things you're given, things you are knowing, you got to put it all together. That's a mixture. It's almost like every other line is deductive, inductive, and it goes back and forth. You have to mix them both together. That's what science teaches you how to problem solve. You're going to need that today, like the concept of what you have to do. It's not easy, but it is possible to figure it out. Okay? The 5-step plan in mathematics, you read the problem for understanding. You will need to do this multiple times today to understand what you're looking for. You're going to have to plan for a solution, come up with ideas of how to solve it. I'll try to walk you through a couple steps here today as we get to your problem. You need to look at the facts that are given and what you still need and what you can, come down to figuring out. Determine your operations you're going to need, or determine things you need to do. Then just do the work. That computational work is all inductive. You have to adapt to a new problem that you've never seen in your life before. I promise you've never seen this problem before. And you have to check your answer and make sure that it makes sense and that it follows all the rules that were given to you. Okay, does that make sense? Okay, I'm not trying to scare you. I'm trying to say that this is a puzzle, and I think you're really going to like it today. It's something that a lot of people would never experience in their life. Okay? All right. Conditional statements. This is something you need to know. We're going to talk about conditional statements. It's a type of statement that's used that gives you two parts. There's an if-then part to the statement. That's how they're going to write formulas and theorems and postulates down for you from now on. From this day on, when you get to theorems and properties in math, they're going to use an if-then statement. It has a hypothesis and a conclusion. The hypothesis is the if part. The conclusion is the then part. Like if, hypothetically, if this were to happen, then, conclusion, this should happen. Like if it rains today, then I'll use an umbrella, right? If is the hypothetical, then is the conclusion, then I'll use the umbrella, if it rains, right? So it's a hypothesis conclusion. This is something we're going to come back to. I'm going to come back to this slide when we get to regular book work, not this like little puzzle we're about to do today, right? Using your logic skills. One of the parts is called the conjunction of a sentence, and there's going to be a disjunction. These are major parts of using conditional statements. If-then statements, there's two types. There's conjunctions and disjunctions. Not just the parts of the statement itself, like the if-then part, but I'm talking about the way you actually structure sentences and say them out loud. You actually always use conjunctions and disjunctions. You don't realize you're doing it a lot, and that adds to like the truth of the words that you're speaking, right? So these are the parts we need to talk about. Most people can understand if, then, hypothesis, conclusion, but these are the parts you need to see the differences. Make sense? So let's talk about the different things we're going to do, because we're going to come back to conjunctions and disjunctions. But conditional statements can be, you can always come up with counterexamples to them if they're really poorly worded. What I mean by a counterexample, let's say I said, if you're listening to music, so that's your hypothetical, if you're listening to music, then you're using an iPod. I just dated myself, no one uses iPod anymore, but if you're listening to music, then you're using an iPod. What's a counterexample to that? What would be something that you know, like if I'm listening to music, does it have to be an iPod? What's another example? Phone. You could be listening to your phone instead. That's a perfect counterexample. You're still listening to music, the if part's still true, the then part, their conclusion is wrong. You used a phone. You could have used a radio to listen to a live band. You could have had a record player, maybe your old school vinyl. You could have used your computer, like your Chromebook. Like you can use other things. But the counterexamples, they have to follow the hypothesis. The hypothesis has to be true. The conclusion they came up with is wrong. We can do that in mathematics all the time. Now, converse is something where you rewrite the sentence differently. We're going to look at that probably tomorrow. We'll look at negations. That's a part of what we're going to do tomorrow. Or I shouldn't say tomorrow. I should say maybe Monday. But these are the parts of like when you have a really bad counterexample, maybe you should reword the sentences a little bit sometimes. And then we'll eventually talk about biconditionals. Biconditional is one of those things that it's a play of words. It's using, like all these other ones, right? Counterexamples, the converse negations, they use if-then statements. But a biconditional says the sentence completely different. Because you're going to see conditional statements say, if this, then this, that type of thing. But biconditional is when they use if and only if, the words. I guess I didn't have it on the next slide. Let's keep going. There it is. So, if-then statements, right? X implies this, right? But biconditionals use the words only if. They use the words if and only if. So it's a way of like rewriting sentences, and instead of always saying if this, then this, you could say it different ways, but you see this in math sometimes. They use the words if and only if. Those are called biconditional statements. They work both ways. You have the front, you have the back. So I'll wear a sweatshirt if and only if it's cold. So if it's cold, I wear a sweatshirt. If I wear a sweatshirt, it's cold. They go hand in hand. Didn't matter the way you wrote it. You're going to see that in our little game today that we're going to play, right? That it's going to test your knowledge on, conditionals, how they write sentences down. Questions at all about what a biconditional is, how they rewrite sentences? Now you're thinking, okay, Ward, what are we doing today? I don't understand. I'm going to give you a story problem, but it's not really a math story problem. It's a logic puzzle, and you have to figure out the final answer to it. But you have to see how they're reading the sentence and all the parts. So the different pieces you're going to see today. You're going to have conjunctions today. What a conjunction is, this thing I had in that slide a couple slides ago. Conjunction is when they use the word and. This and this. For lunch day, you're having milk and salad. So the word and means you include both. It better be both at the same time. If they don't give you both, they're lying to you, right? They use a symbol sometimes. They use a little up arrow sometimes. That means and. That's the actual notation for a conjunction. So instead of saying the word and, like you don't want to physically write A and D, you could put the little up arrow key. It means and. But it includes both. So milk and salad bar. Fine. Have both. A disjunction is when they use the word or. So we'll get to that here in a second. Questions on what a conjunction is. You're going to see that in our little puzzle. I need to kind of clarify what it means. When you have the word and, it means you have to have both at the same time. But a disjunction is when they have or. One or the other. And an or, they use like a little down arrow. Instead of an up arrow key, they can use a down arrow key. It almost looks like the letter V. Between two things. Now, you're going to have salad bar or pizza. Fine, it's one or the other. You can't have both. You're going to have one or the other. That type of thing. Okay, do we have the ideas of these words? Okay, ands, if-then statements, what they are. We're going to come back to this slide like pretty much Monday. I think we'll come back and we'll kind of clarify some of the stuff. But you needed to know some of these words before we get to our little puzzle today. Okay, so here's what I'd like you to do. I'd like you to get in groups of 3 or 4. 3 or 4. Move around, push your desks next to each other. We'll straighten up the desk later. Go around and move, but you have to be in groups of more than 2. So it's got to be 3 or 4. I don't care if you don't get along. Move, right now. You need to move. This piece of paper I'm going to give you, your name needs to go on it. You're turning this in for homework tomorrow. This is a grade tomorrow in the grade book. Don't lose it. Don't drop it. Don't feel like you're just going to copy off your neighbor. And don't use pen. Alright, hey, did everyone hear this? Do not use pen on this piece of paper. You need to use pencil because you're going to make mistakes.
Oh, no way, these.
The fact you've even seen one on everyone in your group will need one. Now, you'll need somebody in your group right now to really pay attention to the board and write down all the notes I'm about to tell you. Okay? So you'll need, put your name on your paper, your name, not your group's name, but your name. And here's what we're going to do. This is called a logic grid. It's testing your ability to take information and come up with a conclusion. It's a brief story. There's usually some background to it. It's kind of fun. It's an actual game people play. All right. Now, you will need somebody in your group to write down all the steps. There's a bunch of slides here. You'll need this information to come up with your final answer today. Okay? Alright, you guys ready? Is somebody in your group ready to write down and be very clear in the words they write down? I'm going to start and stop the camera here just so we have the whole thing recorded. Okay, first slide here. Okay? I need to zoom out a little bit. Okay, the logic. This is the idea of what a logic grid is. It's coming up with a reasonable, conjecture. It's a valid conclusion to a statement, right? The definition of logic is using reasonably conducted or assessed according to strict principles of validity. What I mean by that, it's a really fancy way of saying that you need to follow all the rules that I give you on this slideshow to come up with a valid answer for your problem. You will need to use the grid to help you, and I'll explain. I'll do the first couple for you, okay, on that grid, so you know how to fill it in, okay? Because you can see a bunch of stuff written on that grid, okay? It's like a Sudoku. There's one answer, one correct answer. It's not a free-for-all. There's one answer, and there's one way that you fill in the grid. You can probably see on that grid there's a bunch of people's names, there's a bunch of countries, there's a bunch of colors, correct? They all have to go hand in hand. So each person will be matched up with a different person. They'll be matched up with the country, they'll be matched with the color of the country. And they're just randomly picked. So don't feel like, oh, the US is blue. It doesn't have to be that. Okay, it's random. I picked random colors. Okay, but in a Sudoku puzzle, if you've ever done a Sudoku, you have to fill in the grid with numbers. The numbers can only go in one certain spot, but you can use the clues to figure out, oh, this number has to be in these two boxes. It's one of them. It's the same thing here. That's why I give you a lot of boxes to fill in. Okay? Okay, so this is a Sudoku, right? You can fill in the numbers and all that good stuff. This thing will be the same idea. It's a grid, you're going to have to fill in the numbers, they go in certain spots. So the logic grid itself, here's your story problem. Okay, you have a bunch of bobsledders for the Olympic team. They're in dire straits, pun intended. No one can remember who their partner is, what country they're from, and what bobsled they have, what color bobsled. So, because they misplaced everything. You need to figure out at the very end of this logic grid who the partners are, what country they're supposed to be from, and what color bobsled they have in front of them. Does that make sense what you're trying to find? Using this grid. Okay, so let's get to all the clues, because this is just the story. This is the background. Every logic grid always has a background story. This is your background. Okay? So again, you're trying to match the bobsledders with their partners, the countries, and the sleds, so the Olympic can continue. The Bob process doesn't know. Okay, are we ready to go? Everyone ready for the clues? Okay, first clue. Betsy and Phil are the green sled duo. That means on your grid, if you're looking at it, so if you're looking at the grid and you got, I don't know where Betsy is, let's say Betsy's here, and so here's Betsy and here's Phil, right? You need to put that these two are partners together. So maybe you need to put like, maybe you need to like, you're gonna say, you're gonna like circle this. I have no idea. I don't know how you're gonna mark that. It's whatever your group wants to signify like those two are the partners together. So you're using the column and the row to match. Everyone else, so maybe there's Ted, maybe there's Mark, I don't know which names I picked for you guys. Whatever the names are, then that means Betsy cannot be any of these. Betsy's not partners with Ted, she's not partners with Mark, she's not partners with the other Zane and whatever the other names are. Kind of remember which ones I picked. Okay? So you're going to mark those all down. That also means that Phil isn't partnered with anyone else, like maybe there's a Stacy, and maybe there's other people. Okay? That means Phil's no partners with these other ladies, so you can put X's in their boxes. So you can fill in the grid pretty quick. You also need to mark that Phil is the green color. So maybe down the road, so down the road on your logic grid, they have colors, right? Green, red, blue, black. Across from Phil, you better put that he's in the green and that he can't be any other colors. So red, black, blue, so you put X's for all those other colors. So you're trying to fill in this box pretty quick. That means that Mark and Ted cannot be red, or cannot be greens, because only Phil can. Each guy is matched with a girl, so it's each guy's marked with a girl, and they have a certain color of their sled and a certain country. They're the green sled duo. In unrelated news, Phil doesn't like Betsy very much. Okay, does everyone understand how you're supposed to fill in the grid?
Mm-hmm.
Okay, now you got the idea what you're doing here. You're trying to figure out just the pairings. The problem is you don't know the country of what they're going for. So now you gotta use all these other clues to figure this out. Okay, here's the second clue. The Romanian team doesn't use the red sled. So, you can go on your grid, figure out where Romania is, you can mark red, you can put an X in there. They don't use red. So find that in the grid. That's clue number 2. Next, Bobby does not use the black sled. Bobby does not use the black sled. Figure out Bobby doesn't use black. Okay, we go with the third clue. And remember, you should be writing these down to remember some of this stuff. You shouldn't just be marking the boxes, you should be writing down clues. Number 4. Phil does not sled for Canada or Romania. So you can mark that off. Now, Phil's is marked with who?
Betsy.
He's marked with Betsy. So she's not for Canada or Romania either, because they're the same duo. So they cannot be for Canada or Romania. Does that make sense how you can compare those together?
Yes.
That's a conjunction, that's an and. Phil and Betsy, they're together. That's both. They cannot be Canada or Romania. Okay, we good so far? Hopefully you're writing down clues, at least one person in your group is writing down the exact wording I'm giving you.
Zach?
Okay?
Every word for word.
Okay, next, clue 5. Connie is German. And she would never be caught dead in a red or blue sled. So Connie is German, she would never be caught dead in a red or blue sled. Now, what you should be thinking right there, if you're making logical conclusions, what does that tell you about Phil and Betsy? Just think about that. What does that also tell you about Phil and Betsy? Connie's German, right? So Phil and Betsy can't be German. They're duos together. They're not a duo with Connie. So you can start to match things together. So you can mark Phil and Betsy are not German. Because Connie is. Clue 6. Ted and his partner drive the white sled. They're on the white sled. And they are not from the US, Germany, or Romania. So if Ted is not from Germany, who does that throw out?
Connie.
Connie. Connie is German, so Ted is not a partner with Connie, so you can mark those two off. They're not partners together. You can start to see how all this grid is starting to fill in now. So Ted and his partner on the white sled, he's not from US, Germany, or Romania. And you can start to throw those, those other people out when you start to see that they're using certain colored sleds and stuff. Okay, we good so far? Anyone still need this? Seventh clue, Lulu is from the US.
America.
America. Lulu is from the US. Okay, wait, group just got those written down. Jane does not use a blue sled. Jane does not use the blue. Lance is not from Germany. So So who does that throw out for Lance?
Connie.
Connie. Connie's German, so he can't be partners with Connie. Connie's German, he's not. And he does not use the red sled. He's not from Germany, and he does not use a red. Okay, you have all your clues. I'll put this on cycle, so it will keep flashing through. You have all the clues you need. That was all 9. You need to put them together. I need to know who partners are. Start eliminating and make sure the grid is filled in. If you cannot fill in the entire grid, you'll never figure it out. The entire grid is required.
So Phil is no maple or Roman.
Right, I'm gonna put the camera on the cycle.
That's because you assume there's not any of these, right?
Yeah.
We said Lulu can't be partners with who?
Connie. No, that's the white
So
side.
either say Bobby.
Ted is?
Yeah.
So you gotta remember Connie is German.
Oh, no, I did that one.
Yeah.
It's matched guy and girl, right? For partners? Okay. I'm ready.
That's confirmed.
I should put that there.
That'll stay in a loop so you can see it in case you forgot one of the clues. It flips every 3 seconds or so.
So wait, no.